Hey geometry team, welcome to Unit 12, Day 3. This is Mrs. Cerna, and today we're going to be talking about conditional probability. So in the last lesson we talked about compound probability, the probability of two or more events happening together. Conditional probability is the probability of an event occurring knowing that another event has already occurred. Okay, so it's conditional, so that it is dependent, and it's called conditional because now you have a probability within another probability. You have a probability of the first thing happening, and then the second one is a piece of that. And the way we write that is that probability of B given that A has already happened. And we use this up and down line to say given that A has already happened. And finding this probability of B given A is found by taking the probability of both things happening. This is supposed to be an A given B. So just what we found before, our compound probability, out of the probability that A will happen. So it's the probability of B happening after A given that A has already happened. So this is your formula for that. Let's see what that looks like in real life and see if that helps you kind of understand what this looks like in practice. So for my first few questions, we're going to assume that we choose a number of 1 through 20 at random. Okay? And so we want to know the probability that a prime number is chosen given that we're choosing numbers greater than 8. So starting off with, I need to find the probability of a prime being bigger than 8. And so I think, okay, what are some primes bigger than 8? I have 11, 13, 17, and 19. So there are 4 primes greater than 8 out of 20 numbers. So that's my probability of A and B both being real. Well, I'm trying to find the probability of this prime number being bigger than 8 out of the total probability. So that's going to be out of the probability of having prime numbers. Well, the total number of prime numbers is going to include 2, 3, 5, and 7, which is going to be, okay, sorry about that. And so we had 4 primes that were greater than 8 out of 20, and then we need to see the probability of A. Now notice A is the second thing, so I need to know how many things are bigger than 8. Well, that's 12 things out of the 20. So I've got a 4 out of 20 chance out of my 12 out of 20 chance. And when I do the math on that, I end up with 1 out of 3, which comes out to be a 33% chance of getting a prime given that I'm looking for numbers bigger than 8. Okay? The main thing to watch out for here is that A is the second thing here. This is B, this is A. So when we're finding that probability and we're using this formula, remember we're doing B given that A happened first. So for number 2, I'm looking for the probability of getting a multiple of 3 given that I'm looking at odd numbers only. So first I look for the probability of being an odd multiple of 3. And so I think, well, my multiples of 3 are 3, 6, 9, 12, 15, 18. And so the odd ones are only 3. So I have 3 out of 20 odd multiples of 3. And then I want to know the chances of that happening given that I have odd numbers. Well, my odd numbers, there's 10 of them out of 20. And so I'm doing 3 20ths out of 10 20ths. And when I simplify and reduce this, this comes out to be 3 tenths, which is about 30%. For my third probability, conditional probability, I want to know the probability of having at most 15 given that I have a perfect square. So the first thing I'm going to do is look for the probability of both things. So something that's a perfect square and at most 15. Well, that's going to be 4 and 9, and that's all. Oh, sorry, and 1. 1 is a perfect square. So I have 3 perfect squares out of 20. And then the probability that it is a perfect square, but not at most 15. So I think, well, how many perfect squares do I have in all of my numbers? Well, then I can include the number 16 in them. And so then I have 4 chances out of 20 to be any perfect square. So I have 3 out of 20 chance out of a 4 out of 20 chance, which is going to give me 3/4, which is 75%. Now, if you're getting confused about how I'm doing this, remember that when we divide fractions, we multiply by the reciprocal. So if I'm doing 3/20 divided by 4/20, I'm really going to take that and do 3/20 times the reciprocal. And those 20s are going to cancel, and I end up with my 3/4. So that's what's happening here when I make that jump. Okay, anytime we do these divisions, you're going to be multiplying by the reciprocal to get these fractions. Number 4, I need to know the probability of choosing 7 given that I've picked something no more than 12. And so I think, okay, what is the probability of both these things occurring simultaneously? So I need to know the probability of 7 and not being bigger than 12. Well, the only way I can get a 7 that's not bigger than 12 is to get a 7. And that's 1 out of a 20 chance. And then I say, okay, well, what's the probability of not getting bigger than 12? Well, that's 12 things out of 20. And so when I do this, the 20s cancel out, and I end up with a 1 out of 12 chance, which is about an 8.3% chance of getting a 7 if I'm picking no more than 12. For questions 5 and 6, I have a bag that contains red marbles, blue marbles, yellow marbles, and white marbles. I'm going to be looking for the probability of getting a red given that I did not draw a blue. So my chances of getting red and not being blue are, let's see, how many things are red and not blue? Well, there were 8 and 2 is 10 and 4 is 14 and 6. There are 20 total. Okay. And so you go, what are my chances of being red and not being blue? Okay. Well, that's going to be, let's see, I have 8 reds and all of them are not blue. So I have 8 possible ways of being red and not being blue out of 20. And then I think, okay, well, how many ways do I have to not be blue? Because we're going to assume that I'm drawing out a not blue thing in the first place. And, well, since there's 2 out of the 20 that are blue, there will be 18 out of the 20 that are not blue. And when I simplify this out, I end up with an 8 out of 18, which is 4/9, or about a 44.4% chance of getting a red, given that I did not get a blue when I draw out of the bag. For number 6, my probability of getting a yellow, given that I did not draw a white. And so you think, okay, what is my probability of both these things occurring simultaneously? Well, I have 4 yellows, and how many of those are not white? All 4 of them. So I have a 4 out of 20 chance of being yellow and not being white. And then I say, okay, what's that chance happening out of given that I don't have white? Well, I have 6 white marbles, so that tells me I have 14 not white marbles out of 20. So that's a 4/14 chance, which is a 2/7. And that's about a 28.6% chance of drawing a yellow, given that what I drew was not white. So remember, this is this happening after this one, knowing this one's already occurred. So I knew I didn't get a white. So I knew I had a 14 out of 20 chance. Then we're asking, what is the chance that out of that, it was yellow? Okay. So now we're going to look at this spinner. It's going to go from letters A to P. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 total spaces on this spinner. I need to find the probability that I will land on a shaded space given that I landed on a vowel. Okay? Well, what are the probability of getting a shaded and a vowel simultaneously? Well, here's a shaded vowel. Here's a shaded vowel. Oh, this vowel is not shaded. And here's a shaded vowel. So I have 3 out of the 16 total that could be shaded and a vowel. Now, we're going to find the probability of this happening if I drew a vowel in the first place. Well, how many vowels are there total? I have A, E, I, and O. So there's a 4 out of 16 chance I'll get the vowel in the first place. So if I have a 3 out of 16 out of a 4 out of 16, that's a 3 out of 4 chance, or a 75% chance, that if I already got a vowel, that it's going to turn out to be shaded. And let's look at that, really. Here's a shaded, a non-shaded, a shaded, and a shaded. So I do have 3 out of the 4 that are shaded, exactly as I would have predicted using this formula. The probability that I've got a consonant given that I don't have a shaded one that I spun. So let's first find the number of ways that I can have a consonant and be unshaded. So here's an unshaded, here's an unshaded consonant, here's an unshaded consonant. Oop, that's an unshaded vowel. Here's an unshaded consonant, here's an unshaded consonant, and here's one. So 1, 2, 3, 4, 5, 6 out of the 16 are unshaded consonants. But remember, we're saying I'm going to be given that I already know that I had an unshaded space. How many unshaded spaces are there altogether? Well, there's 1, 2, 3, 4, 5, 6, 7 of them. So I have a 6 out of 16 chance of getting them both out of a 7 out of 16 chance, which simplifies to a 6/7 chance, which is about an 85.7% chance of getting a consonant given that I had done something unshaded first. Number 9, I'm going to choose a card at random from a standard deck of cards. Remember, a standard deck of cards has 52 cards in it. Find the probability that the card is an ace given that it is a diamond. So you think, okay, so that's the probability of ace given diamond. So you think, okay, what's my probability of being an ace and a diamond at the same time? Well, there's only one ace of diamonds, so it's 1 out of 52. And then I go, okay, what is my probability of just having gotten a diamond in the first place? It's 13 out of 52. There's always 13 of each suit. And so my probability of getting ace, given that it's a diamond, is going to be 1 out of 13. Which, if you think about it, in the diamonds, there are 13 diamonds, and one of them is an ace. So this does make sense logically with what we know about cards. And if you're curious, that's about a 7.7% chance. Okay, let's look at some more examples. Just the more you do it, the better and more comfortable you get with it. So here we're going to choose a date in the month of September. Remember, September has 30 days. 30 days hath September. Find the probability that it is an even date given that it is before September 20th. So I'm finding the probability of an even date given it's before the 20th. So the first thing I need to do is find the probability of being an even date before the 20th. And so that's going to be, let's see, the 2nd, the 4th, 6th, 8, 10, 12, 14th, 16th, and 18th. I can't pick the 20th because that wouldn't be before the 20th. So my probability of both of these things happening is 1, 2, 3, 4, 5, 6, 7, 8, 9 out of the 30 days are both even and happen before the 20th. Then you go, okay, well, we're going to assume that I'm picking a date before the 20th. So how many total things happen before the 20th? Well, that's 1 through the 19th. So that will be 19 out of the 30 days in the month are before the 20th. And so this is going to give me a total of 9/19ths as my probability, or about a 47.4% chance. Number 11, The probability of Jasmine studying for a test and getting an A is 13 out of 16. Oh, nice. They gave us the probability. If the probability that she studies for the test is 9 at 10, find the probability that she'll give an A given that she studied. Okay, so we're looking for the probability of getting an A given that she studied. Okay, so the first thing I need to do is, let's see. I know this probability. The probability is 9 out of 10. So I already know my number on the bottom. It's 9 out of 10. Now I need to know the probability that she's going to study and get an A on it. Oh, look, that was given to me. I was given the probability that she'll study and get an A is 13 out of 16. So now I can put this together. And remember, when you divide, you're really going to be multiplying by the reciprocal. And that's going to come out to be 65 over 72 when you simplify all this down. Okay? And that comes out to be about a 90.3% chance. So if she studies, she's got a really good chance of getting an A. But she has to study first. Okay? Number 12. A car lot has both used and new cars. 86% of the cars on the lot are new. Out of those, 45% are new and have a sunroof. So now you're going to find the probability of randomly choosing a car with a sunroof, so the probability of sunroof, given that it is a new car. So you go, okay, well, what are my chances of it being new? Because that's going to be the bottom here. Well, I was told that 86% are new. So I have 86%. So 86 out of 100 are going to be new. And then what are my chances of having a sunroof and being new? Oh, that's 45% or 45 hundredths. You could also write this as decimals if you wanted to. And so when you work this probability out, it's about 0.523 or 52.3% chance of randomly choosing a car with a sunroof if you are giving that you picked a new car in the first place. Alrighty. Moving on to now trying it out with Venn diagrams. Remember, for a Venn diagram, the total in the whole problem is adding everything up. So here I have 24 people who just drink coffee, 12 people who drink both coffee and tea. So now I'm up to 36 people. 4 people who just drink tea. So now I'm up to 40. And then 10 who don't drink either. So I'm up to 50 people being asked if they drink coffee or tea. Let's see the probability of different things. So the probability that someone drinks coffee given that you know they drink tea. So you go, okay, well, what is the probability that they do both? That's going to be here in this intersection. And so it's going to be 12 out of 50 out of the total number of people, the total probability that they will drink tea. Well, the probability that they drink tea is going to be 12 and 14, which is 16 out of the 50. So I've got 12 out of 50 out of 16 out of 50, which comes out to be 12/16, simplifies to 75% or 3/4. Okay. To find the probability that a person does not drink tea, given that you know they do drink coffee. So if you know they drink coffee, what's the chance that they don't drink tea while they drink coffee? So you think, okay, so I need both of them happening together, not drinking tea, but yes, drinking coffee. So I don't want this one because it drinks tea. I don't want this one because it drinks tea. I don't want this one because it doesn't drink coffee. So all I have left is 24 out of the 50 people who do drink coffee and then, but don't drink tea. And then I'm going to say, okay, well, how many drink coffee altogether? Well, that's 36 out of the 50. And so this will simplify to 24 out of 36, which simplifies to 2 out of 3, which is 66.6 on forever %. my probability that someone is going to not drink coffee given that they don't drink tea. So first I need to find all the people who don't drink coffee and don't drink tea. And you find that, oh, that's these ones right here. They don't drink coffee and they also don't drink tea. So I have 10 out of the 50. And then I'm going to say, okay, given that I don't drink tea, well, I know that 16 people do drink tea, so that's going to give me 34 people who don't. So I'm going to have 34 out of the 50 who don't. And so when I put that together, that's 10 out of 34, which is going to simplify down to 5/17, and that's about 29.4% that don't drink coffee if you already know that they don't drink tea. Right? Last section. Of the 400 freshmen at Westview High School, 92 are in band, 60 are in chorus, and 20 are in both. I'm going to draw a Venn diagram for that. Okay? I know 92 are in band. I know that 60 are in chorus, and 20 are in both band and chorus. Okay? And I know there's 400 total. So if I have the 92 and the 20 and the 60, 92, see, 20 and 60 is 80 plus 9 is 172 total there. So 400 minus the 172 is going to be 228 that aren't in it at all. Okay? Oh, wait a minute. I calculated wrong. Did you notice what I did? I did wrong stuff. Mrs. Cerna goofed. So on this, when it told me that 90 students are in band, that included the 20 students that were in both band and chorus. And so I have to redraw this, because if I know 20 students are in both, then in order to get 92 being in band total, that leaves only 72 who are just in band. Okay, so that's my band people. And then if 20 students are in both band and chorus, in order to get a total of 60 being in chorus, that means only 40 were in chorus alone. So this gives me 60 being in chorus. This gives me 92 being in band. Okay? And then I need to know my total probability. So you go, okay, there are 400 freshmen total. I have the 72, the 20, and the 40. So 400 minus 60 would be 340 minus the 72. So that'd be 2. 13 minus 7, 6. 10 minus 2. So 268, sorry, that aren't in it. Had to do a little bit of mathing there, and I didn't have a calculator by me. So now that I have built my diagram correctly, now I can start to calculate my probabilities. So the probability that I'm in chorus, given that I'm in band, first I look and see, oh, there are 92 band students out of the 400 total. And then the probability that I'm in chorus and in band at the same time is only 20. I did that backwards. The probability that I was in both is only 20. The probability given that I'm in band is 92 out of the 400. So that gives me 20 out of 92, which is 5 out of 23. That's approximately 21.7%. Now I apologize for having all my words mixed up. It's the end of a day, and I am not wording very well. Let's try another one to see if I can do it without being confusing. I need to know the probability that I'm not in band given that I'm in chorus. So I'm going to be looking for both of them at the same time, not being in band, but yes, being in chorus. So not being in band is everything but this. But if I also need to be in chorus, that's just 40. So that's 40 out of the 400. And then on the bottom, I need the probability that I will just be in chorus. Well, that's 60 out of the 400. So when I simplify that out, I have a 40 out of 60%, or 40 out of 60 chance, which is about 2/3 or 66.6%. So if I know I'm in chorus then I have a 66% chance that I'm not in band. That's what we're talking about here. I know my chance of not being a band if I know I'm in chorus. Here I'm going to look for the chances that I am in band given if I'm not in chorus. So first we find the probability of being both in band and not being in chorus. So here's all my band people, but I don't want to count the ones who are in chorus. So that leaves me 72 out of the 400. And then my total number of people who are not in chorus altogether is going to be the 72 and the 268, which is going to be 340 out of the 400. And so I have a 72 out of 340 chance, which simplifies to 18 out of 85. That's about a 21.2% chance that I'm in band given that I know I'm not in chorus. So again, for these ones, remember it's going to be the probability of both happening out of the probability that the given thing happened. And that will tell you the probability that the first thing happened given the other. All right, team. Good luck. Have a great day.